everyone, welcome to my channel Learn with Gunjan. Today we are going to talk about deep learning. So deep learning is associated with machine learning and artificial intelligence. If you want to know how, there is already a video out there describing the difference between machine learning and artificial intelligence. We are also going to refer ChatGPT a lot in this. And if you want to know what ChatGPT is, there is already a video out there. So those will be background work needed here. So whenever we talk about machine learning, it's about learning from data, right? And deep learning is the subsection of machine learning where machines learn from data using neural networks. Now, what is neural network? That's how human brain learns. We have neurons in our brain and that network with each other, and that's how the information gets transferred between different neurons, and that's how humans learn using neural networks. So in computer science world, all that is created artificially using artificial neural networks. And what those artificial neural networks are, they are interconnected nodes. Essentially, think of each neuron as one node, and the interconnection between them is how we created the artificial neural network in computer science, and that's how deep learning happens, and machine can learn from using the neural networks. Okay, so ChatGPT, as I mentioned, it's a deep learning model. We will touch upon that in this video. And like we see that there are a lot of usage like human like text generation as well as summarization aspect in ChatGPT. All that is deep learning. Okay, so like I was giving an example. So think of each neuron as one of the nodes in here. And there are three major layers, essentially: input layer, and there are hidden nodes, and then output layer. So input and output will always be there, right? But the hidden layers, those can be like 1, 2, 3, or there can be multiple hundreds of layers depending upon how complex your model is. But this is the fundamental how neural networks are designed in computer science. So each node equivalent to one neuron, and the interconnection between them. So you see that input layer, each node is connected with each of the nodes in the hidden layer. So that's the interconnection, and there is the weights assigned to it so that it knows that which are more important or less important things to consider. Very much like how human brain works. We know which these are more important things to focus on versus not. So similarly, in artificial neural networks also, the weights assignment tells which nodes should you next talk to and how that connection should happen. So that's about artificial neural networks, which is the foundation for deep learning. Okay, so now if I were to make a comparison with machine learning and deep learning, so like I was giving you the example, like what are the important things? That essentially is called as the features. For example, like if I have to say differentiate between a car and not car. So I need to know what makes a car. So that's like the features, right? Like car would have tires and chair would have legs. So that kind of things. So that is the features. In classic machine learning, those feature extraction, like we decide those features. Another example I would give you, like if I have to do the prediction for the airlines prices, or for that, different features would be starting point, ending destination, and then you also need to know the day of the flight, right? Day and time of the flight, because that's the biggest feature which decides the price of the airlines for that particular time. So those are the important features extraction. In classic machine learning, those features were extracted by like data scientists first and decided that these are the key important features, like in the case of airlines, saying that the time of the airline is the biggest feature that you need to focus on. And that is fed into the machine learning algorithms. Whereas in deep learning, that work of identifying what are the features in my data, which are the more important features, and based on that, assigning weights to them, all that work is done by the model itself. That's why it's neural network, because it has way more processing power and way more intelligence into it. Okay. So now, when we talk about this deep learning, where is it used? It is used everywhere. You are using it day in, day out right now, I can tell you. So like when you post your photographs on Facebook or anywhere, it can tag, okay, this is your photo, this is your friend's photo. What is that? Image recognition. What is that? Based on deep learning. And then right now you're watching this video. At the same time, YouTube is doing the transcription of it. It's really converting all the words that I'm saying. It's really putting it to text. What is that? Speech recognition. What is it based on? Deep learning. And natural language processing. You go on Google Translate, somebody speaks in French and you talk to them in English, and that how you can do the translation. What is that? That's again machine translation based on natural language processing, which is essentially what? Deep learning. And sentiment analysis, like you have tons of reviews, for example. In there, you can see what are the positive reviews or negative reviews. So identifying the sentiments in the text, again, based on deep learning. So all these are various use cases of deep learning, and we are using it day in, day out. And now we are getting a deeper understanding on this, okay? So all these things I talked about, image recognition, speech recognition, natural language processing, what is it based on? Lot of data, because it's a huge amount of data that we deal with in deep learning especially, and the algorithms are way more complex. Why? Because like I told of feature extraction, now model is doing it. So the model is based on very complex mathematical computations it is doing. It's based on the complex algorithms. And another big aspect is the data can be either, you can give the labeled data or you can give unlabeled data. It works with both. So that's why it's way more complexity in the model itself, in the neural network itself. And when it is learning from all that data, you need to have high-end infrastructure to train that. That's where the data centers have to be built, and a lot of like cloud computing comes into way, because in cloud you can have all that infrastructure for you. And of course, training these models is the biggest cost that is involved. But these are very complex mathematical operations which are performed by these neural networks. And I'll give you the key types of neural networks which you see every day in your daily life as a usage. So CNNs, so that's specifically used for the computer vision. And when I say computer vision, like classifying cat or a dog, and like when you use your Ring camera, okay, there was a movement, there is a car just went by your house. So that's object detection. It is able to detect the object. It is also using CNN. CNN is a type of deep learning neural network. Okay. Now, on your when you use your iPhone or any of your smartphones, you can use just by the facial recognition. You can log into your iPhones. So that essentially is providing what? Again, based on CNN. It's based on neural networks and deep learning. And then for the medical images, like looking at the X-ray and seeing if this person has a disease or not have a disease, or all that image analysis, that aspect is again done by CNN, which is convolutional neural networks. Now, next is which you use exhaustively in your daily life. Like I gave you the example of speech recognition. They're based on RNN, which is recurrent neural networks. So now when we talk about speech recognition, like you are seeing all that transcript being generated by Google, right? So that essentially is using what? RNN. And Google Translate, again, it's based on RNN. Because when you talk about recurrent neural networks, it works with stream or the sequential data, and that's because it can deal with the sequence of data. It can deal with sequence of data in time series also. So that's why, like any predictions you have to do, for example, stock price prediction or housing price prediction, that again uses RNN. Next is transformer. And why am I talking about it? Because ChatGPT essentially is based on transformer. So transformer is again another kind of neural network. And here the aspect of processing, which is processing the sequence of data, is done parallelly instead of sequentially. So that's what makes it very fast. And there is a very famous paper, Attention is All You Need, which ChatGPT or any sort of transformers for the GPT are underlying using. So we will have a separate video coming out for that. But essentially what these transformers enable you to do is text generation. So like GPT is able to generate the text for you. It can summarize the text. So those are the key features which are again done by what? Done by these neural networks, and under all these fall under the category of deep learning. So if you like this video, subscribe, like, and learn with Kunjan.